It's pretty straightforward. It's just a matter of getting your variables accounted for the right way, and so you'll see as we go just what that really amounts to. But I gave you the screenshots of pretty much what I'm looking for as you go through this. So the general form for a sphere is using subscripts, but subscripts are a pain when it comes to GeoGebra, so we tend not to. So all you're really asked to do is pop in this equation. Most of the time it'll give you the equation in, or identify all the constants for you in the form of sliders. If not, then you might have to make the statement. But I'll type it in and we'll see how it goes. So x minus a squared plus y minus b squared. I don't even know why I'm looking. Y minus b squared. Well, I know why I'm looking, to see if, to make sure I'm consistent with the instructions, plus z minus c squared equals d. Alright, so you hit enter, and it doesn't seem like it did what we needed it to, but if you scroll up, you can see all the sliders were produced there for you. Alright, so it understood that the only variables in play here should be x, y, and z, and that everything else should be a constant. Right, so I can go around, I can play with those sliders. I'll play with the C slider, for example, and see what's happening there. Seems to be moving along the z-axis. All right, so that gives you a little bit of an indication of what it is that I'm looking for there. All right, now when it comes to the next one, because the directions here say what did each of the constants control, be specific and use correct vocabulary. So there is a writing piece here, but you'll find a lot of consistency from one quadric function to another. So the A, B, and C values are going to really represent the same thing, regardless of the quadric function. Right? So you could just say for all of them, A gives us this, B gives us that, and C gives us that. Right? It's the denominators. What's different from one quadric to another. That's what you're really going to have to address. Now you look at something like the ellipsoid and you see b sub x squared, b sub y squared, and b sub z squared. It's like, okay, this is starting to get a little crazy. Just bear in mind, you can work off of the same GeoGebra for this because we've already designated that a, b, c, and d are sliders. So we're just going to let the sliders represent constants within the ellipsoid model. All right, so what I'm going to do is start typing. The a, b, and c's will occupy the same position within the ellipsoid function, so x minus a squared, but this time over a new constant, so divided by, now this is a unique constant. Now there is a way to get subscripts on GeoGebra, but again, it's a pain. You can see that I did it, or I didn't do it. I used a different way. I just used B1 as an expression. But what we can do is just keep going down the alphabet. So I mean, we don't need a D in this one, so use the slider D for the first denominator. All right, plus y minus b. It's grown up right before our eyes. Over e plus z minus c squared over f equals 1. You just got to be cautious, because if you're using as a constant something that's already designated as another value, then it might cause a problem. So I'll hit enter on this and you'll see. All right. So what it did here is it thought E was Euler's number E. So that's a problem. So what I would do is I would just go back and I would change that to an F and change my F here to a G. All right. So basically skip all the important, it didn't let me make the fix. Okay. Well, unfortunate, but I'll delete. A, B, C, D, E. We got an F. All right, so then I'll just fix it here. Duplicate it, and I'll just clean it up on the fly. Sometimes it gets weird with the editing, as you know, when you're dealing with the Bezier curves, right? So this is going to be equal to 1. So this is my D. We can't use E, so I'll use F. And G. So you want to stay away from I also, because I is the imaginary number I. All right, so it accepted it seems anyway. All right, now it's related to the same constants as before, so you kind of run into a little issue there. You're like, oh, well, what did I get out of this? All right, well, I'll turn this one off, and then I'll play around with the constants here. Okay, so still shifting up and down. But now if I play around with the G, the F and G, you could see that interesting things are happening depending on the value of G. The F and G, all right? So D, E, F, and G are affecting the shape of this thing, and what you want to do is try to determine in what way it affects it, other than saying the simple terms, makes it wider, makes it skinnier, you know, like that. You know, we want to use proper vocabulary. Now, not that I expect everybody to go running to the internet for their responses to this, but, and I'll turn off the ellipse here so you can see, here's my circle, here's how it compares to the ellipse, all right? Circle, sphere, I mean. This is not a concept that I invented, all right? The concept of quadric functions, all right? So just Google it. Like if you're struggling on what the constants represent, just Google it, and try to figure it out on your own. But when push comes to shove, there is publications, you know, there are textbooks, you know, the online textbooks, the OpenStax textbook for this course describes what every single constant does. So what I really need out of you is the ability to create the applet, and then also just in reasonable language what each of the constants represents. All right, so if you do that, then you'll have another 20 out of 20 for a tech assignment. All right, and so and that would be it for the course.